Great, awesome. So welcome. This is the Northwest Eco Building Guild's July Education Webinar, Passive Cooling Strategies for Homes. We'd like to thank our sponsors, Pathway Design and Construction, 475 High Performance Building Supply, and King County Green Tools. I have a couple of announcements before we jump in today, but I'd like to thank you all for joining. I'd first like to pause and provide a land acknowledgement. The Northwest Eco Building Guild acknowledges that we work on the unceded traditional land of the Coast Salish peoples, specifically the First People of Seattle, the Duwamish people, original stewards of the land past and present. We honor with gratitude the land itself and the Duwamish tribe. I will post in the chat a local resource and organization called Real Rent. You can do something today to stand in solidarity with the first peoples of this land by paying real rent. All funds go directly to the Duwamish Tribal Services programs and support the revival of Duwamish culture and the vitality of the Duwamish tribe. I'll post in the chat a link. And then we also welcome you all to learn about the traditional Indigenous lands you live on by visiting Native Lands website, that I will also post in the chat. We understand not everyone's coming from Seattle or the Western Washington region. So welcome again. This event is being recorded. A recording of this event will be made available to registrants who registered for the event via Eventbrite and Northwest Eco Building Guild members about a week after the event. So if you have to hop off early or join late, no worries. A link to the recording will be provided as long as y'all are members or registered through Eventbrite. Please mute your microphones during today's presentation. There will be time after the presentation for questions and in-depth discussion as we are a live audience today. So we kind of like to set up the Zoom meetings this way to allow for people to share their camera if they'd like and unmute themselves to ask questions to the speaker. If you have any logistical questions or challenges, I'll go ahead and post my email and my phone number in the chat and can help answer any questions you might have to reconnect to the event tonight. I'd like to start real quick with some sponsor highlights. We'd like to thank Pathway Design and Construction. They create beautiful, intelligently designed living spaces for discerning homeowners in the greater Puget Sound area. Founded in 2008 and a boasting team with well over 100 years of combined experience, their full-service remodeling firm uses sustainable, efficient processes and materials to craft healthy homes. Pathway's mission includes ultimately extending beyond designing and building the places where people live, work, and play. They believe they have a duty to protect their planet and future generations, both as professionals and as individuals. They support initiatives that promote stewardship and social responsibility, and view their role as being a leader among the builders and thriving, environmentally conscious community of Western Washington. Thank you so much, Pathway, for sponsoring tonight's event. Our other sponsor for this evening is 475 High Performance Building Supply, a longtime Guild member and sponsor. 475 has a passion for building science, sustainable material use, and passive house design for protecting the environment and making the world a better place. 475's mission is to supply essential materials, building components, and knowledge that will lead a transformation of the North American construction industry toward making durable, high-performance passive house and zero-energy homes. Whether your next building project is a new building or a retrofit, residential or commercial, a passive house, or just a really durable and comfortable building, they look forward to working with you. I'll post all of our sponsor links in the chat later, but thanks again so much for 475 for sponsoring tonight's event. And lastly, I'd like to thank King County Green Tools. King County Green Tools is a program designed to help all King County stakeholders green their built environment while addressing critical environmental issues such as global warming, habitat restoration, solid waste reduction, and community planning. Green Tool provides technical assistance, hands-on training, and policy development through community partnerships in public and private sectors. I'll post a link to their great link for resources and documents on a variety of green building topics and policies also put in place throughout King County. They're a wonderful resource, and I highly recommend checking out their website. Thanks, King County Green. Wonderful. And the fun part, I'm excited to introduce some of the upcoming events the Northwest Eco Building Guild has planned. In July, we will be hosting a webinar incorporating biophilia in your next residential project. This will include an array of speakers talking about biophilia design, whether a house's or a project is a remodel or a new construction. There's some really neat design strategies to incorporating more biophilic and nature in your next residential project. August 23rd, we have our Northwest Eco Building Guild annual picnic at Ravenna Park. Please join us for refreshments, pizza, and just great networking to hear what folks are working on. September 27th is our September education event about all electric homes. We'll be hearing from speakers in the industry and HVAC industry on strategies for heat pump retrofits, as well as getting some experts in technical resources for battery storage and battery backup systems for homes looking to go all electric. Should be a really great discussion, and a couple folks to speak about case studies on electric ranges and fireplaces. September 28th is our annual multifamily symposium. This is a great event if you're interested in learning more about what folks are working on in the multifamily realm. We'll be talking about healthy and sustainable built environments. There'll be several builders and architects that will be speaking to the latest in multifamily residential building, as well as kind of the upcoming Washington State Energy Code and how that's impacting the multifamily market and strategies for meeting those energy efficiency credits. So, and I ask everyone to check out our website, ecobuilding.org, and consider becoming a member today. Members get access to all events at discounted prices. You get access to all of our monthly education series, like the one you're attending today, for free. You also get access to our member-only content and event replay page, which is the swath of just great webinars and trainings and tutorials on how-tos for your next green home building project. You also, your company and yourself is featured on our Green Pages directory, which we feature often on LinkedIn, as well as send out to folks looking for a builder, architect, or a vendor in the area. I think I send the Green Pages directory out to interested folks about at least once or twice a week. We get lots of inquiries on green builders in the area, so really great resource to tap into. We also have a plethora of networking opportunities and then technical expert forums where folks can chat about the solving problems or the latest and greatest of their green home project. That leads me to tonight's speaker. So I'd like to give a huge welcome and thank you to Ted Clifton, founder and co-owner of TC Legend Homes. Welcome, Ted. Ted has a background of 20 years in residential construction industry. He is passionate about the process of drafting a family's dream home and turning it into reality. Building net zero carbon neutral energy homes adds another level of purpose in his work and is motivated in being a leader of sustainability. When he's not building, he enjoys going on adventures with his 3 kids, such as skiing, biking, and camping. That's awesome. Welcome, Ted. We're so excited to have you, and thank you all for participating. That ends my little announcements, and I'll go ahead and stop sharing and give the mic over to you, Ted. Welcome. We're so excited and so grateful to have you tonight as a speaker.
Excellent. Yeah, thanks for the introduction, Nina. I realized I should probably update my bio and picture. I think that might have been 10 years ago. So, but yeah, I'll share my screen just to start. I just have a couple of pictures to show that could be helpful in explaining basically everything we know and have learned about passive solar cooling. So I work with a great team at TC Legend Homes, and also we have a design company, Powerhouse Designs. We do all our own designs now. And not to bore anybody, I'll try to keep this interesting and quick and to the point. For passive cooling, I mean, the reason the house is getting warm is because of the sun, right? And the sun does this very predictable thing. It rises in the east, sets in the west, and at our latitude, it's always at the same angles, the same time of year. And so, in the winter, it gets down to about 18 degrees. So if we're wanting to use passive solar for heating, well, we don't want to get in the way of any of that 18-degree sun, right? Around the equinox, it's 41 degrees, which I think is like 90 minus our latitude, right? And then in the summer, it's up at 64 degrees. And so you can kind of see with this stylized house, which is actually really similar to almost every house we build, we have an eave, the roof line that shades the upper windows during that like peak summer sun. And then the eave doesn't extend so far that it blocks the winter sun. That's like the easiest to shade is all that south facing, glass, all the south facing windows. They're the best to bring in your passive solar heat, and they're also the easiest to shade from that summertime sun. And then downstairs, like if you have a sliding glass door or a taller window, you just need a bigger overhang to block that angle. So it's pretty easy to calculate. You just take your protractor and you mark it at, usually we kind of figure around that 41 degrees, around the equinox. That's when you're starting to think, of switching from heating to cooling. So, east and west get a little more challenging. I mean, the only real way besides like some mechanical movable shading to, shade a house to the east or the west is going to be, movable shading or like a big deciduous tree. And I know in building, you don't always get the chance. This house was a great example of, they already had these great big deciduous trees to the east and to the west. So we kind of plopped the house right down in between them. You can see this house is in the in-between season where the windows are getting about half the sun down low. So, so that's like movable shading for the east and west sides. You have your fixed shading that you can use to the south. You have a lot of different options besides a roof, though. Like if you have a house that's already been built, you may need to put up some sort of solar shades or some kind of bolt-on option. We've used things like this that's just a couple brackets with some wood on top, and that works pretty well to do most of your south-facing solar shading if you have to add it after the fact. So for fixed shading, we've got very easy to operate. It just stays there. Movable shading, you can obscure light in different ways. You can use blinds, you can use sails, you can use vegetation. There are a lot of different options there, for after the fact. Blinds work better if you can have them outside. If there's any way to have exterior, blinds, if you're doing movable shading. Because once the sun's already inside, you kind of already heated the inside of that blind if you're trying to use interior blinds for solar shading, although they're, if they're a really bright color, they're better than nothing. Other things, that may not be as readily apparent, most people, may know about, but night cooling is when you open a window, maybe downstairs and use the stack effect, which is just the principle that warm air was going to rise. Open a window upstairs, open a window downstairs, and you can create a draft going from bottom of your house up to the top. Or, where we live, we have a prevailing wind that mostly comes from the south. And so if you can open a window to catch that at night, you can do night cooling, because often it'll be 50 or so at night. Other things you can do if you're building a new house, we've experimented a lot with earth tubes. I don't have a picture of any of these handy, but where we use tubes under the ground to pull in all the ventilation for the house. And that can cool your house down if there's enough airflow and enough tubing. So, and that you just have to calculate for the size of your house and how much, heat load you're going to have. Another really helpful thing is thermal storage. So most of our houses have a slab on grade, which is a concrete slab on the ground. And that helps keep your house from overheating in the day and store that cool, if you have cool air coming in for night cooling, it'll help store that, that lack of heat during the day when it gets hot. And then, some of the biggest things you can do after the fact or in new construction that may be a little less readily apparent are air sealing, insulation, and controlling just where you put your openings. Air sealing is huge. It might be half of your heating or cooling load. It's just how leaky your house is. And so, we try to aim for that passive house standard of air sealing with every house. It's like kind of the lowest hanging fruit. It's the easiest thing to do with very simple tools. You're talking a little bit of caulking and some spray foam. So, and maybe some gaskets around windows and doors if they're substandard. Back another thermal storage device though that's coming and is really interesting are phase change materials. And so they have some wax that will change phase from liquid to solid at a certain temperature, like say 72 degrees. And so when that gets heated up to 72, the wax melts. It takes a lot of heat to actually melt the wax. And then as it, like say at night, it'll start to, as it cools off with that night cooling, the wax will start to change into a solid again and release all that heat back out. So you can keep your temperature stable with a phase change material. And so far we've costed, it's about half the price of concrete for the amount of heat that it can store. So, but I think, concrete's also a nice floor if you like that look and feel. So the phase change material, I feel like it's up and coming. It needs to come down in price a little bit to be really widely used. The other the other notes on earth tubes, really being able to harvest that 50 to 55 degree ground temperature, that's something I don't think we've used a lot in this area. We've tried it on just 3 houses, and it works surprisingly well for basically almost no cost. You might be like $1,000 in pipe by the time you've built in earth tubes to a house. So back to our drawing here, this kind of shows some of those ideas, some of those techniques. And then mostly I'd like to open up for questions, for some Q&A, because that's it. That's really all I know about passive cooling and all that we've been able to put into practice. It's not a complicated subject, but it does take the implementation. And so that's the part where some consultation can really help to get it dialed in just right.
Thanks, Ted. Yeah, we'll open it up to audience members for any discussion questions. I know I have a couple just saved up here from folks who couldn't make it tonight but had some interesting questions for you, Ted. One of them happens to be, what is your experience with phase change materials? And is there a specific one you've tried or have researched on the market that you might recommend that is applicable in our Pacific Northwest region?
Yes, I wanted to experiment with some phase change materials. So I had about $3,000 I was willing to kick towards research. And so I went online, I found a phase change material. It's possible I can find the brand. I stapled it up on the walls inside my house. So my living room is surrounded with these phase change materials. And it's possible, if I know how to navigate my website, I could find a picture of it. here. Let's see. Let's see if, oh yeah. So here are the phase change materials stapled up in my living room. I don't know if we can zoom in enough to see what brand they are, but it's that. Anyway, somebody might be able to zoom in on that and see what brand. I'm not sure exactly how to do that, but so I put about 3,000 bucks of this stuff in my house, and I calculated it's about half the thermal storage of my concrete floor. And so I was hoping to see like a marked temperature pause as my house, heats up during the day. You can see this picture is obviously from a winter day because the sun is like, beaming right in through the windows. And so this phase change material should be absorbing, heat during the day and then slowly releasing it overnight. And I have all these temperature monitors and humidity, air quality, all these different things all over the house, and I couldn't convince myself that I saw a real difference. I mean, the tricky part is I do also have this concrete slab, and I have 3 kids that are going inside and outside of the house, and so I don't really have the greatest controlled experiment there. But I get the feeling I'd need to put a lot more phase change material in. And this stuff is meant to go in the wall cavity. You can see it's like they're 24 inch by 24 inch sheets that you can staple up in your stud bays. And they make it for 16-inch on center stud bays or 24-inch on center stud bays. And you can fill your walls with the stuff. And I think the idea is you probably need $5,000 or $10,000 to really see a meaningful amount of thermal storage. Did I answer that whole question?
Yeah, no, thank you so much. That's super interesting. We have a couple of questions that got posted in the chat. John Novak and Ryan were interested in learning more about ground coupled earth tubes. Ryan specifically asked, do you have a strategy for installing earth tubes in a way to protect against radon? I know Eastern Washington is an EPA radon zone, I believe 1 or 2. I think Western Washington is in zone 3 or vice versa. But I do know radon is kind of on our minds as we're going about new construction projects, and was interested if you had any information regarding earth tubes.
Totally. So I've 2 different tracks there. One for Western Washington, where we're not so worried about radon. We've recently been thinking, we kind of stalled our earth tube project because we had too many frying pans in the fire as far as new ideas we were trying and thinking about. And now we're getting back to this idea as we're putting more and more houses, we're putting in foundation drains. And so we're thinking, well, if we already have foundation drains going all the way around the house and they're already sloping, so that they drain, it wouldn't be much to just add maybe 1 or 2 more pipes in the ground, and use the foundation drains and these other pipes for earth tubes. So one of my worries in the past, like in my house, I have 4 100-foot long earth tubes, and they're mostly flat, and they kind of go up and down a little. They're just in the before we backfilled the foundation. And so I wonder, wow, what if it ever gets dirty under there? How am I going to clean these out? And so with a foundation drain, because it's sloping, you could just stick a garden hose down there, purge them if you needed to. I found that with a house this size, 4 100-foot earth tubes, it takes the edge off a house that's starting to overheat, like when we have those heat waves, but it's nothing like central air conditioning. It's not as powerful. You'd really need to put a lot into earth tubes to have a super powerful source of cooling. It is enough, though. You can knock your house back 5 or 10 degrees. If I were worried about radon, this house would again be an example of one where it's a sealed pipe. It's a glued together, totally sealed 4-inch PVC pipe that comes up in the mechanical room, and the intake is out in the yard, 2 feet up. So it's not like it's down, it's not like you're getting air from down in the rock. You're not using a pervious pipe. So if I were in a place that had concerns about radon, I would do that. I would do a solid pipe.
Nice. Thank you so much. That's interesting. John Alexander posted in the chat, and also I'll read off the questions in the chat, but you all that are participating this evening, if you have like a follow-up question or want to dig deeper into something, please feel free to interrupt me and share your camera if you feel comfortable, and unmute and yeah, ask your questions. But John asked, have you ever experimented with hydronic radiant cooling in a slab?
Yes. This house also, which is my house, kind of my experiment house, I've been using hydronic radiant cooling for about 3 years now, since it really started getting hot. Because when I built this house, it was, 8 years ago, and everybody knew you were never going to need to have any cooling system in Northwest Washington. So, well, then it started getting hotter and we started needing cooling. And so I've been cooling. I haven't aggressively cooled. Like right now, I have the cooling set at 70, and actually, no, I turned it up to 75. So right now it's set at 75, and it just will keep the house at 75. And unless it were to get up to like in the 90s, it wouldn't really raise. It's a very stable way to keep a house a given temperature, kind of like if you've experienced radiant floor heating. You just keep the house the same temperature. I mean, assuming it's a very well insulated house. I mean, this one's air sealed to passive house standards. It's an 8-inch SIP wall and a 12-inch SIP roof. And it's, for a 3,000 square foot house, its BTU load is about 12,000 BTUs. So that's, pretty well insulated. So, so far I have not done radiant cooling in a customer's house. I still have some worries about, well, what if you get condensation? So you really need to be able to control how much you're opening and closing the doors. Like if it's 90 outside and your floor is at 65, well, that floor is going to keep your house nice and cool. But if you open the door, it's going to condense on the floor. And so what way do you have to get rid of that condensation? And if you have no way to control how often somebody's opening a door, it could make for a really slippery. I mean, imagine if your, smooth concrete floor is wet all the time. So I would do, again, passive cooling in my house. We have one customer that's tried it, and we've, given them all the disclaimers. But I would be careful with cooling with the floor, because there's just no way to get rid of the condensation. You can put a dew point sensor in so that the cooling system will stop if it senses that condensation, but by then your whole floor is wet, or so. It makes me a little nervous to put in a customer's house where you could have someone slip and fall. And so we tend to use fan coil units with our hydronic systems. We'll just put a loop into basically a big box with a fan and a radiator in it, and then blow that cold air around. And then there's a condensation drain at the bottom of that, so we don't have any issues with the condensation. We've also been able to put fan coil in with our ventilation system. So if you're using an HRV or any kind of like HEPA-based air filter intake, you can put one of these. The current brand we're using is the Zender, that they call it a Comfo Post. And so we install that in line. We get those locally from Small Planet Supply, and we install that in the ventilation system. So your ventilation is also able to cool and heat with that hydronic system. So that's kind of our preferred method if you have a hydronically heated and cooled house, is to use the fan coils and the Comfo Post. And then, if you're feeling bold and not worried about slipping on your floors, or you're careful about how often you open your doors, you could definitely try it.
Nice. Thanks so much, Ted. We had a question that was regarding the low E glass windows, and I was curious if you had a photo of it. If not, no worries. But how often do you use those in your projects? And how effective are they when you take into account the cost?
Interesting. Yeah. So we always use a triple pane window that usually have 3 different low E coatings, and they're different on each pane. it's when we pencil it out, and our goal in building a house is always net zero. So we don't do anything um, that's not trying to achieve net zero, or even if solar is not possible on a house, we usually aim for a HERS rating of like 33. So that's a third the energy use as the reference house. So to get their triple pane windows and the low E coatings, definitely pencil out. They're so easy to do when you're building a house and so much more difficult to put in afterwards. So they always make the cut when we're doing budgets and things. There are different low E glass layups though. So the one you see on this house is a 180 I-89. It's the highest solar heat gain. So because I have full shading on all the windows, there's covered porches that shut out all of the summertime sun. I don't mind having maximum solar heat gain, because then I can gain that heat in the wintertime. And then in the summer, the eaves protect the windows, so I don't need the most aggressive low E coatings. So I still have like a U factor of 0.14, which is like what is that, an R7, basically like an inch and a half of solid styrofoam is about the same insulative value as these windows. They also make more aggressive low E coatings that'll filter like 80% or 75% of your solar heat gain. So you're only getting like 25% solar heat gain. Often if we have unprotected or unprotectable west facing glazing, like say you have this great view to the west and you want to have a bunch of western glass, but you don't want to sacrifice your views, you don't want to make these windows tiny, we'll go to like a 366 Cardinal, the outfit that's making the glass for a lot of these windows, is kind of using the same number. So we use like a 360 I-89 or something like that that blocks out way more of the heat gain. And like in that case with a whole bunch of unprotected western glass, you're way more worried about overheating in the summer than you are trying to get that little bit of heat in the winter. So hopefully that answered the question. But yeah, always worth investing in the glass. That's they're one of the biggest energy leaks. I mean, after air leakage, your windows are the next biggest energy leak of the house.
Thanks for that breakdown.
To note that, I mean, if when you're designing a house, like we do energy modeling as we're designing the house, and so we don't have to guess at this stuff. We can, and we use just the simple, like WSU puts out they call it a component performance worksheet, where you enter in your walls and your windows and all that sort of stuff. And then you can see really quickly how much heat you're losing out of your different surfaces. And you can modify those. You can say, oh, maybe it's worth a 12-inch SIPS roof instead of a 10-inch SIPS roof because I have so much roof. And you can play with, okay, 4 inches of foam under the slab versus 2 or versus 6. And you kind of find that sweet spot of like cost versus, how efficient. Because at some point, you're like, well, is it worth putting an extra 10,000 into insulation, or is it worth putting 2,000 more solar to get the same benefit, right? And so there is a point where extra insulation doesn't really get you that much farther. And so if you do energy modeling on your houses, that's a great way to just find that sweet spot.
Thanks, Ted. Yeah, it's a good call out on the energy models, especially the programs provided by Wazoo. Linda asked, do you work very closely with the landscape designers to plan the ongoing effects of keeping and adding the right plantings for the best passive cooling and heating? They don't see always the immediacy of addressing, landscaping, but could you speak a little bit to what investment and perhaps kind of strategies are implemented in the exterior natural landscape?
Yeah, for sure. So that is, for us, that is very aspirational. So our goal is to have every house that we build, to work with a landscape architect and someone that actually puts in the landscaping to get as big a tree as possible on the east and west sides. Have we done it yet? I mean, the only thing we've been able to do so far is situate some of our houses that we've done like out in the county where they do have access to already mature trees. We've been able to situate the house in the right spot to take advantage of those trees. I can only think of one house that we've built where our customers were, I guess had the budget and desire to put a large, mature, deciduous tree right out front of their house. Often, when it gets to landscaping, that part gets cut. It's a real bummer because it doesn't take a lot of landscaping to really add a lot of value, to a house in livability more than anything, really. And so it's an aspirational goal of ours, but we're always battling between trying to keep our housing affordable and, as lean as possible. And it seems like that's one of the things that gets hit on the chopping block quite often.
Thanks, Ted. Claire asked if you could please talk about retrofitting an older house. Theirs was built in 1906, and strategies to include for passive cooling. Opening a window at night is not really an option for them, so just discussing kind of retrofit strategies for an older home.
Yeah, for sure. The first thing that I would do is do the obvious air sealing things like, check out your front door and there might be like a half-inch gap under it. And that could be half your heating and cooling loss right there. After I attacked those like obvious ones, like front door seals and things like that. And sometimes you can just buy a new seal and it's like $10 and you just tack it on with little nails, or sometimes maybe you need a new door or something if your door's outlived its lifespan. But so there can be really cost-effective ways to air seal. The next step would just be having, we use a third-party verifier that also does blower door tests, Elizabeth Coe. She would come in, do a blower door test, and you can walk around and feel where all your leaks are. And so in that case, you can use some, gaskets around your outlets. You can spray foam some different spots. You can caulk, your baseboard trim or caulk around your windows. I mean, there's so many things you can do to, I think a lot of municipalities even offer like a home energy audit where you can get some of this stuff done at a reasonable budget. But usually that blower door test is a couple $100, and then you can addressing those air sealing things. That could be half of it. And I think the numbers that I've heard on a typical old house, it's like that air leakage is about half. The other thing that's probably the next easiest and cheapest thing to do is on a house that old, it might not have any insulation at all. And so you can hire, an insulating company to come in and blow insulation or cellulose or something into your walls. Often they'll offer a service where they just cut a little hole in each wall cavity, blow it in, and then patch the drywall and paint. And people that we've worked with in the past have done some of that patching and painting themselves, or let the insulation company take care of it all. And that's another, it can just be a few $1,000s, and you've gotten another huge chunk of the way there. So just the insulation and the air sealing. And so that way, whatever your active systems are, even if it's night cooling, and I guess if you're not able to open your windows at night for security or whatever other reasons, the next step I would do would be a mini split heat pump. And you don't have to let a heating contractor talk you into using the biggest one that'll power your whole house. You can just use the smallest. We use in a lot of our houses just the smallest, most efficient Fujitsu. The equipment itself is, $2,000 to $3,000, and installation's another $2,000 to $3,000. You might be out $5,000 or $6,000 for that mini split heat pump. And then once you've done the air sealing and the insulation, that mini split heat pump is gonna at least change the temperature of your house by 15-20 degrees. So if it's 90 outside, all of a sudden it's 75 and livable, or if it's 100, it's 85 and livable. So even if you don't invest tens of thousands to get one that's sized to do your older home, you can still get most of the way there with some pretty cost-effective equipment.
Thank you. Going off for the heat pump discussion, JP asked if the heat pump specifically for the hydronic cooling system, if that was a custom design or if that's something that can be purchased as like an off-the-shelf product.
That is a great question. So we're currently using the Chiltrix heat pump. Anyone can buy them. They sell direct. It's really handy to have an installer that's done a couple before, or a heating or a plumbing contractor that's interested, that's willing to do a little troubleshooting and things like that. So far, it's not as plug and play. You don't just like buy it, stick it in the house, and it all works. Like there are a lot of parts and pieces to put together. I just happened to draw up a new diagram for our system. I think I can just hold it up to the camera. Is that legible?
Not really.
Not really. Okay.
Sorry
Well,
about that.
so we install the same system over and over again. We have our heat, we have our air to water chiller outside. It heats, it cools, it does domestic hot water, it does all the house heating and cooling. We have a buffer tank, a domestic tank, various pumps, manifolds, so we do in-floor radiant, we do the fan coil unit, we do the comfort post. We don't really have the capacity to install for other people. We pretty much only do installations on our own homes, but we're happy to give away our design and materials list. And we do offer consultation. So if you wanted to call us up and say, hey, can I buy a few hours of your time, walk me through this, walk my contractor through this, we can give you our design and the parts list, and your installer can go buy the stuff. These systems you have to tinker with them a little to get them dialed in and working right. So it's not like you put it in and walk away. You put it in and you have to come back 3 or 4 times just to get all the little bugs worked out. And then like my system, my house is built in 2015, and I have a air to water chiller. It's a Daikin Altherma, which is what we're using now, is a pretty equivalent, piece of equipment. And I haven't done any servicing to it for 6 years. When I first set it up, there were little, things I had to tweak and work out. I had one fuse go out at one point. They're a very low maintenance system once you get them all set up and working right. So hopefully that answered that question. But yeah, we're happy to give away our design, for free, as long as you're willing to, pay for a few hours of time for us to tell you what it all means and how it works, right? So
That's awesome. Thanks, Ted. John Novak asked if do you also put, say, oh yeah, John Novak, do you want to just ask your question? I don't know if you're online tonight. I can also try to read it off, but I'm curious on what context you meant for the gypcrete on the upper floor levels and the extra mass.
Can you hear me?
yeah,
Yep.
hey, John, how's it
Great.
going?
Well, yeah, I was just curious. I thought I talked to your father once, and maybe he'd put it that just adding gypcrete to your flooring structure. So you have your concrete slab on grade, but add just some thermal mass on 2 inches of gypcrete or concrete or something on the upper floors can also make a big difference through thermal mass.
So we've done that, and I mean, I've used the gypcrete before in a hydronically heated house. I liked it. The houses we did after that one, I liked the concrete floors so much. I just went to the regular concrete, which was, the same cost, but then it's your finished floor. And with the gypcrete, you pretty much have to put something over top of it. So then you have another, $10 a square foot by the time you've covered it with something. So just the straight up concrete is like I like it as a flooring material. Right now,
even on the upper floors?
Yeah, even on the upper floors. Well, I mean, you need the engineering to take it.
Because that's some serious weight, right? Yeah.
Yeah.
Okay.
So yeah, if your house isn't engineered for it from the beginning, you may want to just experiment with this phase change material rather than the gypcrete, because so far it's it's like I say, even at the price I paid, it's half the cost per BTU of the gypcrete or concrete. We're putting a pause on adding a lot of concrete right now because we just started calculating carbon for our houses. So we're starting to not just our operational carbon footprint, but we're starting to calculate our embodied carbon. And as it turns out, these concrete floors that I just love so much are like our biggest are the biggest part of our carbon footprint. And so we're talk to me another year from now when we've puzzled through this. We're just trying to figure out, can we still use concrete for floors? Is it worth it? I mean, it's great durable material. Is it worth using extra of it for thermal mass? I mean, we used to pour our floors just a little extra thick to get more thermal mass, and now we're doing all our floors 3 inches thick instead of 2 inches thick because we're starting to really look at the carbon footprint of what it takes to make our houses. And so yeah, currently I'm steering away from it. The other interesting thing is, I mean, passive, cooling techniques are great, but if you have a really well insulated and really well air sealed house, your active cooling could be pennies on the dollar. So, I'm like, when I heat and cool, I've got a house with a 12,000, this current house that we're looking at, well, I don't know if we're still sharing the screen, but this house at 3,000 square feet is about 12,000 BTUs for heating. My last house of a similar size was over 100,000 BTUs for heating. So, so then once you've got your loads down super low, having a heat pump or chiller that can keep up with it's not, you're not using that much energy. So.
Well,
John Novak, I'll just follow up with your question regarding the Fujitsu systems. Ted, is that your preferred system you use due to its energy efficiency, cost, or why the Fujitsu systems?
Oh, for mini splits, we're using the Fujitsu because the last time I looked, they are the most energy efficient, the highest SEER rating you can get for the dollar. They're like 33 SEER, I think, for their smallest, most efficient mini split. And so, when you're looking at different units, I mean, a lot of them, they're all the same cost, and you've got this one that's like 33 SEER and this one that's 28 SEER, and you pick the 33. Also, just continuity, we've installed like 30 of these exact same units, and so that makes it really fast for us to like if we had to do a different brand, we'd have to stop and read the manual. We're now with this smallest Fujitsu, we don't have to stop and read the manual, we just go and put it in. So it's probably, I mean, someone that's used to installing Mitsubishis or Daikins probably has the same feeling about their equipment.
Great.
Thanks.
And for Ryan's question, kind of getting at your concrete investigation, have you considered earthen floors? And Ryan, if you're on, if you want to describe what earthen floors are, or if Ted, you know what that is. I'm not familiar with earthen floors, but curious of your thoughts.
I am really interested. I mean, from the moment we started calculating carbon footprint, all of a sudden, straw bale houses and I mean, all sorts of other techniques start to look pretty interesting. It's scary to take, we have a system that we've used over and over again and it works great, performs really well. And we've been doing the same thing for a dozen years, mostly this, nearly the same house with just minor improvements here and there. Earthen floors, I don't know anything. This is like rammed earth, I guess, yeah, if you have any tips or tricks or ideas, I'd love to hear more.
Yeah, Ryan, are you on? Do you know any more about earthen floors that you wanted to discuss? If not, we can move on to the next question. I'll have to do some Googling tonight. I'm curious as well. JP asked, what would you recommend for existing west-facing windows? I have one right now and the light is just pouring in currently to reduce solar gain.
I have a few recommendations from, there is a spray low-E coating that you can put on. Then see if I can remember the name of the company that does it. But so you can take a regular window and spray on a low-E coating. They're also like stick-on low-E coatings that you can do. They're also you know, shades, either like white blinds on the inside that'll reflect the sun back out, or you know, ideally a blind on the outside. I know, you know, in Europe, a lot of the houses that I had seen have a just like a motorized, you know, solid blind on the outside. A little bit of a bummer for if you want that light in the west facing view but don't want the heat. You know, you definitely have that to consider. You know, sails are another option, like some kind of fabric or something that you can mount away from the house. So in this house there, you can't see it in this room. That west facing light you see is actually from the south facing windows. But the on the west side of this house there is a west facing window that does get pretty hot, and the way that we've found to keep the sun out is put up a, you know, a south facing fabric screen that just stays up all summertime, and then you roll it up in the winter. So that might be the easiest thing to do if you have the real estate for it, if you have room. It's harder to put up something immovable because, you know, the way that western sun comes in, as you know, it like comes down low and it just beams straight in. So yeah, I would say those would be the options that I would look at.
Thanks, Ted. That's super helpful. And thank you, John, for posting a link regarding earthen floors in the chat. Yeah, there's no more questions in the chat, but maybe what we could do, Ted, is if you want to stop sharing so we can see everyone's face, and I'll just kind of pause and open it up for the floor. And folks, please feel free to, like I mentioned, share your camera if you're comfortable and unmute yourself and ask any follow-up questions to Ted. It's kind of our way of making this event feel more like it's in person, so folks can feel like they can interact and discuss and ask any questions they have. Also, I want to shout out to Newt Logan with Solar Assist. Thank you for posting just that great information in the chat. It's a pleasure to meet folks in the industry and learn more about your experience with some of these strategies. Yeah, any questions?
Earthen floors, that looks really cool. I'd love to check that out more.
Hey, Ted, JP, thanks for all the guidance so far. I have another question, which is about attic ventilation. I don't know if you tend to design or retrofit homes with ventilated attics, or if you try to seal them. But I was curious if you have worked with ventilated attics, what your experience has been with using attic fans in the summer to reduce the temperature in the fans, or in the attic, I should say.
For sure, I have a bunch of thoughts on that. One side note, we don't do attics or crawl spaces because actually I've had 30 years in the building industry now, and in the first dozen, I did build houses that had crawl spaces and attics, and I would end up in the crawl space or the attic, and they're like the least happy places for me to go in a house for a multitude of reasons, rodents and bugs and dusty insulation and all that being a few of them. But if you have an attic, you know, obviously there's nothing you can do to get rid of it. It kind of depends on, you know, where's your insulation? Is your insulation down at the ceiling level, or is it up at the roof level, right? And if your insulation is like blown in down at the ceiling level, well then you may just be able to put in a big attic vent on each end, and that might be enough. Now, because your blanket, your insulation blanket would be at the ceiling level. So if it's a little hot above that, it's not quite as big of a deal. Now, if you have the other situation where your insulation is up at the roof line, or a lot of it's up at the roof line, and then you don't have insulation between your living area and the attic, yeah, then definitely, fan powered, ventilated attic, and it probably takes more fan power than you think. Um, I would look towards where we found the best value right now is like marijuana grow op fans. They have the best controls, and they're really easy to get and hook up and use. They're actually more, they like surpassed builder technology a number of years ago. So we've started using some of these or greenhouse fans or things like that. But they just have, then you can get a fan with like 400 or 600 CFM and really pull the air through that attic. It's like a small like bath fan. It just isn't going to do the job. Oh, really well sealed 1,500 CFM whole house fan. I mean, that would be the kind of power that you'd want to do that. But like I said, we haven't done because we don't do attics.
Well, you wouldn't need to put it in your attic, just put it in your house, right? Like,
Yeah.
just I was just thinking, have a really high window with a really high powered fan in it, and you turn on that fan at night, open all your windows down below, and just blow, just pull massive amounts of air. I don't know how much energy that fan would use, but that would help with the night flush, I would think, and maybe with a well-sealed house and with just doing that strategy, you could get by without cooling,
Interestingly enough, I mean, it really depends on how well insulated your house is and how much thermal storage you have. So in a house like the ones that we do, you don't need any fan. And I'll open, one or two windows downstairs and one or two windows upstairs. And that's actually enough. We have, tilt turn windows. So I'll just open them to tilt. So they're even still secure when they're open. You can lock them when they're open if you want. And just that is enough to cool the house down to, below 70 degrees every night. Even if it's, maybe, 75 or 80 during the day, we'll get down to like, 68 or 70 at night, like with no fan. So yeah, if you added a fan to that, or if you didn't have, tricky part is if you have no thermal storage, cooling it down doesn't last very long. You're gonna, you can cool your whole house down to 68 or whatever, but then, an hour later when the sun comes up, it's going to start to heat up pretty quick. And so if you don't have the thermal storage, you really need some active cooling as well. Or you're relying on the speed of that fan, like blowing by you to cool you. And, that's the way most of the world operates, is you just have a fan like right above your bed, and that's what keeps you cool, which is not, the worst strategy either.
Yeah.
How's your house doing, John? Is it keeping itself cool? And
Well, that's part of my question. I have some window. I kind of wish I put one up a little higher. Like I think I could have put one up higher to really get that opening. But I find that the tilt turns just don't. I wish they opened more degrees,
yeah,
right? Do they make them so they, instead of 6 inches? Because if you put them in a thick wall, then you wrap them with gypsum, they don't, they're sort of sealed.
Yeah, you need that stack effect, or you need the prevailing wind. And my numbers are all from Bellingham too, so I know you're down in Seattle.
That's what I think. I think I'm in the
Like 10
Pasadena
degrees
of,
down there.
I'm in the Pasadena of Pasadena
Yeah.
Ballard, I think, because we're right at the bottom of the hill. So I don't think we get all those natural convection currents to help for wind flow at night.
That's where that heat pump mini split or the air to water
Yeah.
chiller or something would really make up the difference. I mean, like I said, it's like sometimes it seems 10 degrees hotter down in Seattle than it is in Bellingham. So.
Yeah, so the thermal mass is right. So I'm just curious. I feel like maybe doing your concrete option, if it wasn't so bad for the environment on floors, getting that real thermal mass up there, the storage, and then doing, you know, really good night flushing, like I'm talking about, would be a good strategy for some house.
I have to admit, as soon as I started using my chiller for cooling the floors, I'm not as aggressively night flushing. It's I used to be really meticulous about doing it every night, and now because I can just push a button and it works, it's so this is, I know the talks about passive cooling, but you know, there's that balance between how much does the passive work and how much how much is it worth to invest in an active system?
Well, that's the question. How much does it cost to do a, you know, my understanding is if you have a high performance house, then you don't need to cool it down to 68 degrees, the floor. You can cool the house down to cool the floor down to 75 and you'll still be pretty comfortable. And that reduces your, you know, your chances of condensation, right?
By a lot, yeah. I try to aim for no more than 15 degrees below what the temperature is outside. So that means if it's 100, you're cooling to 85.
Yeah. So you're right. So you still need that backup system because we're now going to have those 100-degree days more often, probably. So it's.
Yeah, I think, you know, in the future, at a minimum, having a house that is, you know, getting towards that Hertz rating of like 33 before solar, and then having enough active systems to cool also. I think we'll probably end up wanting both.
But just curious, what do you find a difference between a heat pump system and a air cooled fan coil system in terms of comfort or anything like that?
You mean like the mini split versus the chiller, or
versus mini split versus what looks like a mini split on your wall or in your ceiling that blows cold air, fan coil basically. Because you know, I'm just trying to think maybe we should be getting away from heat pumps because of the CFCs in them or the refrigerants, and going air to water is more efficient.
well, I mean, they're all heat pumps. They all still have a refrigerant in them. It's just, you know, with the chillers, that refrigerant is located all outdoors in the outdoor unit. And then with the mini split, it's a split system, meaning the refrigerant, you know, is split. There's an indoor head and an outdoor head, and the refrigerant goes from inside to outside. They're still basically using the same technology. I mean, the actual refrigerant they're using, like the R410A or whatever, is a lot more eco-friendly. I just actually got my refrigerant handler's license a couple of years ago because I figured I was monkeying with these systems enough. I wanted to kind of take it to the next level and know really how they work. And so they've done away with most of the really bad systems out there. Everything we're putting in new houses is like 100 steps ahead. I mean, there's old equipment out there where, you know, old commercial refrigeration equipment, which is really gross, and they actually allow a certain percentage of like leakage every year. So if we're looking at like refrigerants and the good ones and the bad ones and what we should be doing, I mean, any brand new equipment you buy and put in a house is amazing compared to the old equipment that's still out there. It's like, I mean, there's still coal-fired boilers out there. You know, it's more like, yeah, if we could replace some of that old equipment, you know, with some newer, that would be a really good idea.
And the code is changing pretty soon here to have even better refrigerants. A little more explosive, quote unquote, but they're all used.
The hydrocarbon based ones are a little more explosive, but not as much of a global warming potential. So that's, you know.
But yeah, I mean, I'm just curious. I guess you'd have to worry about condensation if you run a heat pump line inside your walls from the outside, right? So if you're just running water, because split systems use a lot more refrigerant because they're running all that refrigerant through all those lines, right?
Sure.
Versus where it's self-contained in a little box, much less amount of refrigerant, much less likely to leak out. because
less chances for leaking for sure, because you're not piping it all through the house. I mean, that said, you know, you're still, either way, you're still insulating those lines, so you don't have the condensation issues. But as long, you know, as long as the lines are well insulated, and wherever your fan coil head condensation drain, that handles your practical like condensation.
yeah, that's right. It's true.
Yeah, that makes a lot of sense. Linda, I saw your video on. I didn't know if you had a question. Just wanted to triple check. Didn't want to miss anyone, but great questions, John. I wondered that as well as the new 2021 Washington State Energy Code updates come into effect. We also have a webinar for that. So again, just a little plug to become a Northwest Eco Building Guild member. We had the wonderful representatives from the Northwest Energy Efficiency Alliance and Better Built Northwest provide us the presentation on the upcoming 2021 Washington State Energy Code. Great questions, John. Anyone else have any questions for Ted?
I don't mind wrapping up early if there aren't any more questions. I just got to Whistler with my kids and they're wanting to head to the pool.
Oh, so fun. Well, enjoy. What a great time. And I want to say thanks again for posting. Yes, a SCS conference is coming up soon in Boulder. I am not sure as well if the solar decathlon is. And prior to everyone departing tonight, I will send out in the link. There's a really great tool the USGBC program provides. It's free online to download. It's the LEED heat island reduction calculation tool. It's very useful, and I'll post in the chat a link, but I'll also follow up in a couple days with with the link to today's recording, a link to the USGBC's LEED online tool that helps calculate your heat island based off of paving materials and your square footage of your vegetated area. It's a nifty tool just to see how you're doing landscaping and also albedo wise of that heat island that's generated from the materials such as your roofing materials and your paving materials. So just a neat tool for new construction projects or existing homes that I can also share as a link. Pretty self-explanatory calculator that you fill out. And if you're interested, I can walk anyone through that as well. Yeah. Thank you all so much. Ted, I appreciate you. We had a couple of cancellations for some other speakers due to some family emergencies. So we really appreciate you being our speaker tonight. So thank you so much. And I hope you have a wonderful trip with your family in Whistler. And thanks all for joining tonight.
Thanks, Ted.
Okay, thanks everybody.
Thank you. It was great. Thanks.
Good chatting with y'all.
Thanks very much.
Thanks. Bye.
Here.